The next topic that we're going to learn about is, drumroll please, trigonometry. So we finally get to the trig part in the course. So we're going to look at the very basics of trig, which you probably have some background from in integrated algebra. If we have a right triangle and we're given two sides, so in this case we're given the legs are 18 and 24, and we need to find the hypotenuse. So if we're given two sides of a right triangle, well then we could use the Pythagorean theorem. So a squared plus b squared equals c squared. And we would substitute in what we know. 18 is a, 24 is b, and we could solve for c. So we could use the Pythagorean theorem and get c is equal to 30. Now if we are only given, say, one side and an angle, well then we have to do something different, and that's when trigonometry comes into play. So trigonometry is the study of triangles, and we're going to look at the relationship between the angles and the sides of a triangle. The angles and the sides of a triangle. And we are going to be looking at the triangle from the perspective of a given angle, and we can label that angle as x, or as this symbol here, which we call theta. That's just a Greek letter, and we see that a lot in trig. We'll use this symbol instead of representing the angle as x. The first thing that we're going to want to practice doing is labeling our triangle in relationship with a given angle. So if we take a look at these examples down here, the angle that we're looking at is located over here, so we're going to call it x. Now if you remember, the hypotenuse is always opposite your right angle. So in this case, this side is our hypotenuse. In relation to this angle here, the side next to that angle that's not the hypotenuse is called the adjacent side. And the side opposite the angle is called the opposite side. In this example down here, here's our angle. So opposite our right angle is the hypotenuse. Next to the angle that's not our hypotenuse is the adjacent side, and opposite the angle is the opposite side. Examples 3 and 4 you can try on your own. To solve triangle problems for the lengths of sides or the values of angles, we're able to use trig functions. And the trig functions are sine, cosine, and tangent. So as you might recall, there's that the saying SOHCAHTOA. So the SO part stands for sine of theta, sine of the angle, equals opposite over hypotenuse. Cosine of the angle equals adjacent over hypotenuse. And tangent of the angle equals opposite over adjacent. So we need to be able to label the triangles, and it's going to determine which one of the trig functions we're going to use to solve the problems. So right now we're just going to practice figuring out each trigonometric ratio. So sine of b, well, let's take a look at our angle b. So here's b. So sine is opposite over hypotenuse. So if we're looking at the perspective of angle b, our hypotenuse will be over here, the adjacent side is over here, and the opposite side would be the 9. So sine is opposite over hypotenuse. So our opposite side is 9, hypotenuse is 15. So the ratio is 9 over 15. Cosine of b, so once again we are looking at the perspective of our angle b, so we don't have to change these. So cosine of b is adjacent, so the adjacent side is 12. So adjacent over hypotenuse. 12 over 15, because our hypotenuse is once again 15. And tangent is opposite over adjacent. Our opposite is 9. Our adjacent is 12. Okay. Now if we are looking at the sine of c, well, that's going to change things a little bit. So now if we're looking at angle C from the perspective of angle C, well, 15 will still be the hypotenuse. The hypotenuse never changes, that's always opposite the right angle. Now our adjacent side is going to be the side right here, that's 9. And opposite will be over here. So the sine of C, opposite over hypotenuse, so 12 over 15. Tangent would be opposite over adjacent, so 12 over 9. And cosine would be adjacent over hypotenuse, so 9 over 15. So now we're going to look at a few examples where we need to use our trig ratios to either solve for the length of a side or the measure of an angle. So in this first example here, we're told that ABC is a right triangle and the hypotenuse is AB, and that measures 15, and the measure of angle A is 35 degrees. We want to find the measure of the length of BC. Okay, so first thing we need to do is label our triangle from the perspective of our angle. So here's angle A, that's the angle we're dealing with. So the hypotenuse will be AB, opposite will be CB, and adjacent will be AC. So the two sides that we're going to be dealing with are the hypotenuse and the opposite side. So that means we're going to use the trig function sine. So to set it up, the sine of the angle, so sine of 35, because we know our angle is 35, equals opposite, which is x, over hypotenuse, which is 15. Now we can put sine of 35 over 1 and cross multiply. So x equals 15 times the sine of 35. So now we're going to want to put this in our calculator. What's really important is that we are in the right mode, so click mode on your calculator and make sure you're in degree mode. We're dealing with degrees, 35 degrees, so we want to be in degree mode. Now we can go ahead and put 15 times the sine of 35 in our calculator. And that is going to be 8.6. So the measure of the side is 8.6. Looking at this next example, it says find the measure of x. So in relation to this angle here, we have the hypotenuse, we have the adjacent side, and we have the opposite side. So we are dealing with adjacent and hypotenuse, so that's going to be cosine. So the cosine of the angle, so cosine of 56 equals adjacent over hypotenuse. So we'll put cosine of 56 over 1 and cross multiply. So x cosine of 56 equals 14. To solve for x, we need to divide both sides by the cosine of 56. So 14 divided by cosine of 56. So that's going to give us x equals, and then we want to put 14 divided by cosine of 56 into our calculator. 14 divided by cosine of 56. And that gives us 25. We'll take a look at one more different type of example. So it tells us the length of the leg BC is 15. Well, that's not good. Better hurry this up. So the length of BC is 15. The length of leg AC is 20. So our triangle needs to be labeled like this, where the hypotenuse is left alone. Now it says find the measure of angle A to the nearest degree. So let's call this theta. We'll get in the habit of using that symbol there. Okay, so we are dealing with, if we're labeling the sides, adjacent opposite, and hypotenuse. So we need to deal with opposite and adjacent, so that's going to be tangent. So the tan of theta equals opposite over adjacent. So what's going to be different about this one is we are solving for an angle. So in this example here, our keystrokes in our calculator will be a little different. What we want to do is tan inverse of 15 over 20 equals the angle. So when we do that in our calculator, we need to hit second and the trig function, 15 divided by 20, and then our angle is going to be about 37 degrees. So theta will equal 37 degrees. So whenever we're trying to solve for an angle, we're going to need to hit second sine, second cosine, second tangent, and then put in whatever the fraction is, whatever the ratio is. Okay, so tomorrow we're going